Okay, so let's start today. So the second chapter is about software quality and quality in use. So we are going to see how what actually this quality term is in respect of software maintenance and what this quality in use is, like when the software is actually being used by the user, how we can say the software has high quality, or can we say this thing or not. So these are some things that we need to know in terms of software. So in my last class, if you remember, I talked about indicators of system decay. I talked about how system gets degraded over time, right? When you use a particular software or a system over a time, gradually it degrades its quality. So right now we don't know actually what the quality is, but we are going to see what quality is in this 8 factors. So in this slide, if you can see the rounded circles, they actually indicate technical issues. So, for example, over rely complex structure. So I told you how a particular system can become a complex. For example, for example, a software is being developed, and in multiple iteration, if there are some changes is being done, and those changes actually are not are just being done to fix those problems at that moment of time. So in that case, it might happen like you are not documenting, or you are just fixing that particular issue. You are not checking actually what is going to be the impact of that changes on the whole software, because that is not our concern at that moment of time. So we are just focusing on fixing those problems at that moment of time. So this can actually result. So this is one of the example I'm giving you. So this can actually result in a complex structure of the whole software. The other problem that we saw was running in emulation mode. You are using a legacy language, for example, a very old programming language for COBOL or some other programming language, and you have developed a software, and now you want to use that particular software on, let's say, Windows 10 or Windows 11. You can do it. You can have your own environment, and based on your own environment, you can actually run the software. But again, it will be a short-term solution, because the performance and security is going to be hampered if you are doing this thing, means running a software in emulation mode. Third was very large components. If you develop very large components, so large components means the line of code can be very high. It can have too much of lines of code, and each, like, what will be the problem if we have a very large component in this case? How actually it is going to impact the overall software degradation? So this can happen because if you have a very large component, maintenance of that large component will be very difficult. If you do some changes on that component, you may not know like what impacts that particular thing has on other component, right? Because handling a very big or very large component is always challenging task, and maintaining a very large component is again a very challenging task. So that this is why we make our components small and modular, right? We don't make the components too big. However, if you see these 3 circles, so these 3 factors are actually the technical issues which actually makes the software degrade, means the quality gets degrade over time. If I talk about from technical issue. However, if I go to management issue, these 2 factors were more about management. The first was deficient documentation. If the changes that has been done, they are not properly documented, whatever things, or it's not only about the changes. It starts from the day one, from where actually you gather the requirement from the user. If all those informations are not properly documented from day one till maintenance, then this factor actually is going to come under management issue. The management was lazy. They were not active to ask the people in the whole team to document the whole process. The second is high personal turnover. Like I told you, in software company, it is very usual. The people will go, people will come. So hiring and firing thing happens very fast. And if a particular software is being developed by by some people, and if they go, let's assume if they leave the company, it may happen they may not have transferred the whole concepts to the people who actually are left over there, or to the people who are going to join after they go out of the whole company. So high turnover, how it is going to impact? Because if a particular software is being developed by a set of people, and if they are not available at that moment of time, means during maintenance, this can also impact the whole software degradation process. But these two factors actually comes under management issue. However, if I talk about quality issue, in quality issue we have these three factors. The first one is frequent failure. If there is frequent failure, the question comes to the reliability of the software. Whether for example, the software which is being developed, uh, if by passage of time there are multiple failures that the users are encountering, then it means we can say the software is not reliable, right? Excessive resource requirement. The software which was developed, now it needs more resources to do its computation. Maybe it can be because of the technology that was being used, maybe the programming language, anything that was used during its development. Now it demands more resources to do its computation. It can be also because of the load of the data. Earlier, it was designed to handle only 100 users. Now, because of the gradual increase in the company, you have 200 or 300 people, and it cannot tolerate this high volume of users or people. So for this, it demands more resources. So this was the second thing. And the third was different technologies in one system. So when you put multiple, or when you use different technologies in a particular system, the integration problem can happen. You may not be able to integrate all different technologies properly, and then because of this integration, the overall degradation of software can actually happen, right? So if you see these 8 bullet points, what things actually came out of these things? So there are 3 main things that actually came out from these 8 points. First was technical issues, second was management issues, and the third is quality issues. So we saw why actually we are getting technical issues, right? What actually is the management issues, and however, and the third one, what actually is the quality issues. All 3 of them are very important for us, but right now we are going to concentrate only on the third one, which is the quality. What actually is the quality, right? So the first thing which comes in the mind is, what is quality? What you think? What is quality? Yeah, any one of us, what you think, what is quality? In software term or in any general term, what actually can be the quality? Can we define quality? Oh, those questions are second and third. But let's talk, what is quality? Anyone? What is quality? Yeah. Meeting a required specification can be one of the quality of a product. Okay. Anything else? So we will see that like the quality is a subjective term. It changes with people to people, right? It will not remain same for each individual. It is going to change from people to people. And the second thing that the question that comes into our mind is how actually we can measure quality. And the third is how actually we can define quality, right? So if you see how can we measure quality, it talks about when can we say that something has declined too far. So how actually you can tell, like a particular software, how actually you can tell how a particular software is declined, means how a particular software is degraded over a time. How actually you can tell. For example, if a particular software is having a very frequent failure, right? If a particular software encounters a frequent failure, then can we say that like the quality is high or the quality is low? What actually we can say? Low? We can say quality is low. Yeah, but again, we will see whether we can say the quality is low or not. It also depends on many other factors, because it depends, like, for example, what kind of failure actually it is, whether it is hampering the user requirement or not. If it is hampering the user requirement, then actually we can say the quality is low. However, the task for which the software was defined, if it can do those tasks, even though there are some failures which are not directly involved with the users, but it is fulfilling the need of the user, we can say the quality is high, right? We can say the quality is high. So it is an subjective thing that we need to understand, and how actually we can define quality. For example, different project aim to have different types of quality. What can be the example of this? Different projects aims to different types of quality. For example, gaming software. Let's take an example of gaming software. If I talk about a gaming software, if you want to develop, what can be high quality, or what will be the quality aspect of a gaming software? Yeah. Mm-hmm. How about the graphics? It should have a very good graphics, right? And if I talk about a banking software, security, which should be the first? Data integrity, user friendly, yes. Availability, yeah. So what actually you are seeing here is different projects have different types of quality, right? So it changes from project to project. It will change from person to person. This is actually what we have to understand. So if anything is changing from person to person, project to project, then how actually we can define, or how actually we can measure the quality? So this is something what we want actually from this class. So how to identify a high quality? Now again, what is high quality? So this is again a very challenging question. And if you see the example, what is shown on the screen, it talks about 10 interviews was done, and we got 10 different answers, right? Even people who actually are working on the same product, they are going to come up with they are not going to come up with the same definition. For example, if I'm working on a particular software and I'm working on that particular software as a developer, and if you ask me what should be, how actually I'm going to rate this software as a high quality software, I'm going to tell you if this code is written very clean, right? If the coding is very clean, it and other aspects, for example, if the language is up to date. For example, if I'm using the technology of the language, for example, if I'm using the Python programming language, which is enriched with high efficient libraries. So I can tell you if these things are being used during the coding part, I can tell you the quality is high. But this aspect is from developer point of view. If I go in the same product, if I go to the tester, he will tell you like if the product has less bugs, right? If the product has less bugs, then the quality is high. If I go to a user GUI person who actually designs the whole GUI for a particular user, then what can be the factor in that case? So there will be multiple people actually working on the project. For example, there can be a developer, there can be a tester, there can be a GUI developer, right? Who actually develops the whole screen, the GUI, graphical user interface for the actual user who's going to interact with that software, right? For him, it will be like how easily a user can connect with that particular software. This can be something on which he can tell you the quality is high or not, right? How actually it interacts with the user, how actually it is attractive to the user. But how about user? If I talk about the user, then it is going to shift. The user will tell you whether the task for which the software was developed, whether it is doing it or not. If it is doing those tasks, then the quality is high. So you can see for the same product, the software, we have multiple people, and multiple people have their own definition of high quality. So it is going to change from person to person how they see the whole software, and for the whole software, what can be the high quality. So this slide actually talks about the same thing. If you interview 10 different people, you're going to get 10 different answers for the same product. There is no absolute high quality definition actually, right? So there is no high quality absolute definition. You need to define and measure it one way or the another. But the thing that comes to us is, can a product with a faulty design be of high quality? And can product which keeps failing be high quality? What do you think for these two questions? I told you like the scenario, right? The high quality is going to change from person to person for the same product. But how about these two things? Even though we cannot define right now, we cannot define a product is high quality or not till now. But if I ask you these two things, what do you think about what can be the answer for these two questions? Can a product with a faulty design be of high quality? Is it possible? Do you think? Or we should say a product which has a faulty design, it always has low quality. In some case, yeah, it is. It can have both perspective. It can be good, it can be bad. For example, bad means if it has a faulty design, it means it is not covering the whole user requirement, right? Then of course the product can be termed as low quality product, right? However, let's assume in the whole software you have introduced some new innovative features which was not there in previous softwares of the same scale or of the same origin. For example, to solve a particular task, there are multiple software, but in this new software you have introduced some new innovative features which are groundbreaking research actually, right? So they have not been used in the previous software, but you have designed those features for a particular software, even though it has a faulty design. But because of this new feature, we can say that the product has high quality because these features actually was not there in the previous softwares. So again, it is a subjective thing. You may argue or you may not. It is something like this, right? The second thing is, I'm just giving you the both sides things. So can a product which keeps failing be high quality? No, right? It cannot be, but it can be. It has both aspects. It can be. For example, if those failing things is not that much critical, maybe you are using a software and you are getting some alarms in your software which are false alarm for your antivirus, but they are false alarm. But for real attacks, it can capture those attacks. So it is solving your problem, right? But it has some failing thing in it. For normal pattern or for normal traffic, it gives you false alarm, but it is not stopping it. It is just giving you a false alarm. But for correct attack or for the right attack, it is giving you that like there has been some attack coming on your system, and it is giving you those alarms. So it is doing both tasks. So unless and until so maybe this example didn't fit properly here, but the whole thing was like if a particular software you develop and that particular software is actually not has certain features in it which actually doesn't impact the overall user usability, right? Those features those failure things are so marginal that they are not impacting the overall users usability, then we can say the software or the product has high quality. We cannot say that it has low quality, because ultimately it is doing for what it was developed. It might be failing on some other aspects which are not crucial, which are not stopping from the software to be from being used, or it is not stopping the software to do its intended task. It is doing those things. So you can see, right? So even though a software which fails very often, or even though if it has a faulty design, it can have high quality and it can have low quality. So it depends from person to person, from project to project. So this is something which we need to understand. Yeah. Yes, yes, yes. This is those standards actually we are going to discuss in our upcoming slides. How, so if this problem is there, if someone is seeing the same thing from a different lens and other person is seeing the same product from a different lens, then how the quality can come. So we are going to see what things actually should be there, and there are certain standards that needs to be followed for a software product, for a software development actually, right? We are going to see those things. However, if I talk about Garvin's definition of quality, there are multiple definition of quality. It's not one. There are multiple. For example, the first one, transcendent definition. Quality is something that is intuitively understood but nearly impossible to communicate, such as beauty or love. You all might have seen Mona Lisa painting, right? Everyone might have seen this Mona Lisa painting. Everyone says it has a very high quality. The way it has been painted is very high quality, right? But do we understand what engineering or what things were used to actually draw those paintings? Or can we transfer those things to something else and use the same concept to draw a new painting, and we can claim like the one which was used for Mona Lisa, the same thing has been used here. So this one also has the high quality. Can we do it and we can claim it? No, it can't be. So this is exactly what it is telling you. So there are few things which can't be transferred actually. The second is product-based definition. Quality is found in the components and attributes of a product, right? For example, the feature, what actually it is providing. If I have a mobile phone, if my mobile phone has a very good graphics, if it gives you a very long battery life, right? If it charges at very less time period, then I can tell you the product. Then the product-based definition will be, from this product-based definition, I can tell you the quality is high, right? Because the components and attributes of a product is actually fulfilling my demand. The third is a user-based definition. If the customer is satisfied, the product has good quality. This can be also one of the definition. For example, if I am wearing a pair of shoes, and those pair of shoes, if I'm okay with those shoes, they are doing what actually for what I'm wearing it. For example, for the snow, they are working very good. Then I will not care what technology or what material it has being used to develop, because it is ultimately it is serving my needs, and my needs is it should work for snow, right? So if I talk about user, they will be more interested in how actually the product is fulfilling their demand for what they have actually purchased that product, right? Similarly, if I go to manufacturing based definition, so the quality definition is going to change in that perspective. So what it will be, if the product conforms to design specification, it has good quality, right? For example, if you are developing a particular software and it obeys or it follows the whole SRC, then we can say it has a very high quality. Similarly, we also have one more definition, value-based definition, which tells you if the product is perceived as providing good value for the price, it has good quality. For example, if you buy a normal antivirus software, and if it is not the paid one, the free one, but if it is working for your software, it is giving for your system, and if it is giving you the alerts for the attacks, it is working for you, right? So it is value for money. You are paying nothing. Actually, you are paying nothing for it, but it is doing the task for what it was being used. So this can be also one of the factor. So if the value of the product you are paying is less, and still you are getting what you want, we can claim that like the product has high quality, right? So if you see the whole Garmin definition, so the whole Garmin definition is being taken from different perspective. It is not only from one lens. these definitions actually comes from different perspective of the product from being developed to till it is being used. For whole phase, there will be multiple stakeholders which actually is going to see or evaluate your software. So from all of them, means from all perspective of these people, this Garvin definition actually fits for high quality. And now you can think from any of these perspective, like whether the particular software has high quality or not. Now again, service versus product quality. So far, we saw what is product. We were talking about a software, right? So software is a product. Now, if I talk about service, then defining quality will be more difficult than what we were seeing for a product. So for a service, quality is even more difficult to define than product quantity, than the product quality. This often results from wide variation created by high customer involvement. For example, a fountain pen and a food service. Very good example. A fountain pen and a good food service. If I have a fountain pen, it comes under what? It comes under product, right? It comes under product. So what should be features or things that I should look, and then I should claim that the fountain pen has high quality? It writes well, whether it's smooth or not, right? Sorry. It can it should be right in any gravity. Okay. Okay. It should work at any place. Maybe this can vary from person to person, right? Because space people are different from normal user. The fountain pen actually is for the normal user we are talking about right now. Smoothness can be one. Design, how actually it looks. People actually don't buy a simple pen, right? Even though it works, you need a good design. The material, yeah, the build quality, the design material. So these things actually can be some factors based on which we can tell the fountain pen has high quality. But how about food service? How about food service? We're talking about a service. It's not about a product. It's about the service. Let's take a food service example. Yeah, service is delivered quickly. How about the ambience of restaurant? Is it going to impact? Right? If the ambience is very good, so much lightnings are there, and everything is being used very well, you are going to go there, right? And this can be one of the impacting factors. How well the person who is there in the food service, means the restaurant, is attending you. How fast he comes to you and he asks things whether you need something or not, right? This can be one of the factors. Anything else? The food quality, how well they have presented the whole food. It's not only about the food, it is also about the presentation, how you put those food on the plate, right? It goes under the product. Food taste. Yeah, it can go. Yeah, food taste can go. But how about the presentation? Yes. How can the presentation comes under here in service? Right now, if we have multiple customers, each customer has its own perspective, right? He is going to see based on these factors. If I ask him to rate the whole restaurant out of 5, he may the perception can differ from person to person, and he may be he may get attractive by some of the factors, but not with all. He may be looking for how well the food was presented, right? What was the ambience of the whole restaurant? So what you see, the whole quality actually differs, right? The whole quality actually differs compared to a product. So with this example, you should understand, like for any service which we give, to tell whether that service has a high quality, it is going to become more difficult compared to a simple product. Service will be more challenging task compared to a product, always. So if service and product, both things are there, if you see this graph is from from an article which was published in 2008, IEEE software. If you see this graph, we have two axes, X and Y axis. The X axis talks about quality level and the Y talks about the benefit, right? Quality level and benefit. Quality level means the high quality. The more we move towards the X axis, the quality is high. The more we move upwards in Y axis, the more benefits actually the customer can get from the product or from the service. Benefits means ambience, all those things will be there. The more benefit it will go. Now, if you see the triangles, the first triangle, if you see at the bottom, it talks about useless thing, right? So if any product or service that comes under this box, the triangle which you are seeing at the bottom, we can claim it as a useless. Why? Why we can claim it as a useless? Yes, because it has low quality level and it gives you less or low benefit, right? And if you see that utility breakpoint, that point where the arrow is there, it tells you from this level, if you go up, if you increase the quality level, then you will get more benefits. And the second box talks about useful, how actually it is useful for the customer. It may, for example, the same example, the antivirus with a normal user, which is not a paid version, it is a free version. Those things can come actually here. If I'm talking about a product, that can come under here, useful thing. How actually it is useful for you, right? And if I increase the quality level a bit more, so there is one more breakpoint, differentiation breakpoint, out of which if I go beyond this level, then I'm talking more about competitions. There will be multiple antivirus software, right? They all are going to do the same task, but now I'm more interested in more benefits. I'm willing to pay more, but what benefits actually my product is giving? How I can differentiate my product with other products? These factors actually are going to come under competitive part. And if I go beyond if I increase the quality level little more, and there is one more breakpoint, saturation breakpoint. So this means even though I'm investing more on quality, I will not get more benefits. And if you see the whole curve, it is not going like the way it was going from the useless to competitive. So there will be a certain point where adding more features to your software will not give you intended benefits for which actually you were using for what you were designing the whole software. Means this saturation point actually means you are increasing, you're evolving your software, you're adding more features, but even though you are adding more features, it requires more cost, right? It requires more cost, more people, but the benefit out of which you are getting is it's not that, it's very marginal, it's very small. So this graph actually tells you about the quality level and benefit, how actually these two factors actually works with each other. So the next thing is how actually we should invest. So in this graph, if you see, on the x-axis we have investment level or quality, and on the y-axis we have total cost of maintaining and running software and services. And if you see in this graph, there are three different colors curve. The first one is blue, which talks about cost of quality assurance. The second one is red, which talks about cost of fixing things. And the final one is black, which talks to you about total cost of quality, right? Which talks about you the quality. So if you see these three things, what actually you are getting from this graph? What understanding is coming from this graph? So let me tell you what these things first. X-axis, investment level or quality, means how much money, time, effort you are going to invest, talks about the x-axis. Y-axis is total cost of maintaining, the maintenance and fixing the software and services for the whole product and service. It talks about the y-axis. Quality assurance is a proactive approach means you follow certain guidance, certain standards, so that the quality can be assured, it can be maintained, right? Maybe by using better testing techniques, following certain standards that have been developed by ISO, and so on. Cost of fixing things means once the product actually has been developed, now you want to fix the bugs that actually are coming from the software. And this black actually is the total cost of quality, which is going to combine both quality assurance and cost of fixing things. Then we can get total cost of quality. So what can you understand something from this graph? How actually things are working here? Anyone? Yeah?
The cost of the quality will be so high because actually because we are using lower investments.
Mm-hmm.
And otherwise, if we use more investments, we have more quality because actually the quality issues.
Okay.
So there are some kind of trade-offs.
Mm-hmm.
If we're going to have some quality assurance, more quality assurance in our product, it's going to be the total cost is going to be higher.
Yeah.
And otherwise, if you're going to use lower cost of quality assurance because lower investments, again, the total cost of quality.
Yeah, correct. Absolutely correct. So this is exactly what this graph actually tells you. If you see this x-axis and the blue line, and the red line. So the red line, if you see the red curve, actually, I mean the red curve. If you see in the first part, in the first on the left hand side, from the marginal go on the left hand side, if you see it is very high, right? It means you have investment. You have, if you are going to invest less on quality, ultimately you are going to invest more on fixing things, right? Because you have not followed any guidelines. You have just built a product and now it is being used, right? Now during its usage, you are getting more and more bugs, and if you want to fix those bugs, you are going to invest more on cost of fixing those things. And on the other hand, if you increase this investment on what total cost of maintaining and running software and services, you see the cost gradually decreases. The red curve comes down. And the same is with the cost of quality assurance. If you have used those quality assurance during the initial buildup of the whole software, you can see the x-axis, the cost. If you are taking this quality assurance from the initial point, the total cost is less, right? The total cost is less. But if you invest more and more, there will be a certain point of time, like if you see the blue line, the cost is going to be high, but there will be no more impact on the overall quality. So what actually we want? We want a point where we can say the cost, the investment level, and the total cost of maintaining is balanced. So this thing is going to come in the center of the whole graph, where actually you are investing on the level of quality is average, and the same thing goes with the y-axis, the total cost of maintaining and running software, not running, it is running software and services is going to be decided from those factors. Okay. Now this is the standard actually from which we can claim our software has a high quality or not. If any software, so this is the standard from ISO IEC 25010, which talks about quality characteristics. If any software follows these characteristics, then we can claim the software has high quality. So this is the standard which we need actually. So if you see this software or the system or the product, so right now we are talking about product. We are not talking about service. We are in product. So the first point can be functional suitability, whether the task for which the software was developed, whether it is doing it or not, whether it is accurate, correct, and appropriate, right? The second one is performance efficiency. Performance in the sense the time it is using for doing the computation, the throughput, everything comes under performance. Compatibility, whether the software which you have developed whether can it work with other softwares in a system, coexistence, interoperability. Interoperability means actually a particular software, can it actually work in the same domain if it can integrate with other. For example, in blockchain we have multiple different platforms with the help of which you can develop your software, but can you actually interact all of them? If it is yes, it means the software is high interoperability. If it is no, means it is less. Okay. Second is compatibility. Okay, compatibility is done. Next is usability. Usability actually comes from the user point of view, whether it is appropriate, how fast user can learn the software, how fast user can operate. So they are self-explanatory. I don't have to explain these things, so you can just see and you can understand. User error, how many errors user actually is getting when he is using the software. User interface, it talks about actually the whole user interface, whether it is user friendly or not. Same, it goes to the next point, which is reliability, security, maintainability, and portability. So if you see this ISO IEC 25010, if you have this 8 or 9, how many it is? 8. So if these 8 features are there, then we can claim the software has high quality. And you can go through all about these factors, what actually these factors are in more details, right? By your own. I will not explain these factors. I will not go through these points one by one. But it's like, if there are these 8 factors are there, we can claim the software has high quality. So based on a survey, so importance of different types of quality. So there was a survey, means this slide actually talks about a survey which was done, and out of the survey it was found, like for all 8 parameters, all parameters were actually one of the factors for quality. So it's not like if a particular software can have only functional, if it is only functional suitability, if it does what it was being developed, we can say the software is high. It needs all these 8 characteristics. If all these 8 characteristics are there, we can claim the software has high quality. And if you see this this survey, most of them are above 3, right? Most of them are above 3 out of 5. So this can give you an intuition how actually these factors are important during software product quality. Next is ISO IEC 25010, quality in use. Quality in use, once the product is actually being used by the user, then we want to know what can be the factors from which we can claim the software has high quality. That was product, actually the whole product we were talking about. But now we are more concerned about in use. Once the product actually is being used by the user, how we can claim like the software has high quality. And it turns out that there are 5 different factors. Effectiveness. What can be the effectiveness definition? Accuracy, how actually it is accurate, whether it is doing those tasks or not. Efficiency, doing the computation with minimum time period. Satisfaction, whether the user is satisfied by the whole software when he is using it in terms of usefulness, trust, pleasure, comfort. Freedom from risk, when he is using the software, the software should be free from these risks, which talks about economic, health, environmental risk, and so on. And the last one is context coverage, for which means context coverage in the sense it means like the whole software was developed for a particular task. Now, can it do beyond those contexts for what it was intentionally developed? So context completeness and flexibility actually means, first thing is, can it do for the task that it was the task for what it was designed? And flexibility means, can it do something beyond those tasks, which you have not given as an input, but still you have in the software. So this comes under context coverage. So if any software follows or have these 5 properties, we can say the quality of during usage is high. All right. So this model, if you see, this is okay. So this is ISO IEC 25010 measures. So if you see this diagram, we have seen two different models so far, right? If you see the first block, it talks about quality models. So there are two different models. First one is product quality model that we saw, and we need eight different features. If those 8 features are there, we can say the product has high quality, right? Similarly, if you see the last one, which talks about quality in use model, we saw like there are 5 different characteristics, and if those things are there, we can claim the software has high quality. Similarly, we have one more model, which is data quality model, which talks about how accurate, how correctness is there in the data. And this model actually is being used to determine the quality of a target computer system. So we use this to evaluate a particular system, whether it has high quality or not. The dotted, not the dotted, the bold lines which you see, which are not dotted, they actually means what actually they are going to evaluate. And the dotted line which you see in this diagram, these dotted lines are actually the factors which are going to influence while making the decision. So at the bottom, we have target computer system. It means the software for which you want to check the quality. It will be there at the bottom. And based on these different models, you want to assess the overall quality of the target system. And actually, it depends on multiple factors. For example, it also depends on primary, secondary, and indirect users. Primary can be the main user who actually want to use the software. Secondary can be secondary and indirect users. Who can be the secondary and indirect users in this case? What do you think? Primary will be the software, means the user who actually wants to use the software. How about secondary and indirect? Who can be the secondary and indirect users of a software? Yeah, we have other stakeholders also there, but we are talking about the usage. Usage means who actually are going to use the product. Stakeholders can include different people, for example, the developers, testers, and all those people, the policy holders, those guidelines, those things can come under other stakeholders. But how about secondary and indirect users? Owner of the software product, yeah, it can be. And how about the indirect users? You can check what can be the primary, secondary, or user. For if now I know like this, the primary can be the main user, and the usage environment can be the environment actually where you are going to execute the whole software. For example, if you want to use the software in Windows 10 or Windows 11, that thing can actually come under usage environment. And then we have target computer system, which includes computer hardware, non-target software, target data, non-target data. So non-target actually is not going to influence the quality, but somehow they are related when you are assessing the overall quality of the software. They are not directly involved, but they are indirectly involved. However, this target software and target data, this is something which we can evaluate from this whole model. Based on these 3 different models of quality. All right. So if you see this diagram, so the ultimate goal of this diagram of this standard actually is how actually you can assess a particular target computer system that is being developed. And the evaluation actually is going to depend on these 3 different models: the product, data, and quality in use. This is how it goes. And there are multiple other factors: the communication system, which is going to include how the data is being exchanged within the system. Information system can have the hardware and the software things. Human computer system, which is going to include the entire software and the users who are going to use the whole software. So these are different components for ISO 25010 measures if you want to evaluate a particular software. So software quality practical view. Let's see what actually it is. So we saw there are software maintenance actually is about the last two stages where we perform maintenance and then finally we claim whether the software has reached to its end of the product or not. And the other factors are actually in actually the other steps actually comes under software development life cycle, or you can say the whole software engineering methods or models. But if I talk about quality, so there can be multiple quality themes in practical. For example, the first definition, if you see, is quality is conformation to specification, right? It talks about get the specification right and build according to them, basis on the of any model that you use. For example, waterfall approach to software development, or anyone you can use. The second theme, the quality theme can be you cannot inspect quality into a product. It should start from starting. It is not going to come by the end. It has to be done from initial stage. The third one is most problems are a result of a system. Don't blame the workers. It's a management problem. So if in a team, if you have 5 developers and 4 experienced and 1 is new, the new one is in charge of keeping the specification up to date. What could be wrong here? So it talks about if there are 5 people, and if in this 5 people, if 4 are experienced, then you should actually give those tasks to the experienced people compared to the new one. Similarly, it talks about quality is fitness for use, seen in agile approaches to software development. Work closely with the client to make sure you deliver what really he wants. Workers must be empowered by support of top management. Problem in many software development, this is actually the problem in many software development initiative. And do actually we use this process to define the activities or justify them? So these are the questions that comes from workers and from management point of view. And similarly, there are a few more definition. I will not go through those definition, but let me go further. Okay, now let's talk about the key developer practice. So there are 2 points that you need to focus on. There are 2 things that you need to focus as a key developer. The first one is the version control and testing. So we are talking about how actually when we are working as a developer, how actually we can claim like the software has high quality. What actually we can do when we are developing the whole software. The first one is version control, and the second one is testing. So what actually version control is actually about? So if you see the whole process, it talks about different steps that you have to follow. For example, complete 1 changes at a time, and then you should commit it. Don't break the build. Commit only the source file. Use the log by writing a summary of each commit. Communicate with each other who are there in the development team, and so on. So this is how actually you can control the version, and these are some best practices that actually you can follow during Agile Developer. You can go through these slides by your own. And if I talk about these comparisons to this ISTQB principle, the first point is testing shows the presence of bugs. Means testing is going to show you bugs, but it will not tell you the overall problem actually, right? Exhaustive testing is impossible. It is not always possible to test each module or function. So the best approach can be to test something, to test with the existing test case on a relative context, not on the whole context, because testing the whole software can be a problematic task. Test early as possible, because once the product is developed, it is very difficult to it will be very difficult, in the sense the cost and the time is going to be high. So the testing should start as early as possible. Defects cluster 20% contain the 80%. This is very known problem. Most of the defects that you are going to see are going to be in very short are going to be assembled in a very short cluster. It is not like the whole software has bugs. There will be bugs in a very small part of the software, which is only the 20%. Means the 20% of the whole software actually is going to have 80% of the bugs, if I talk about the whole software. So the testing, so whenever we are evaluating or testing the software, we will come up with a point where we can say like in a small fraction of code, it contains the whole 80% of bugs. The pesticide paradox, don't use the same test suits. I can tell you, like, don't use the same inbuilt pesticide paradox here means actually don't use the same test suit to evaluate the whole code. You need to do some changes with some changes in the software. It is not possible like the same test suit is going to capture the whole bugs. Testing is context dependent, absence of errors policy. It means absence of errors policy means it might be possible like there is no errors in the software, but still we cannot claim like the software is 100% bug free. The bugs can actually come when it is being used by the actual users, even though you are not getting any errors or bugs during its during your testing phase. So if I talk about where actually is the problem, so from where actually the problem comes. So the problem comes when we have new code, when we write some new code, we introduce some new feature. If you are more interested in putting new technology in the existing software, if you are changing the source code, if there has been some changes in the last minute just to make the software up and running, you are more dependent on different external or imported libraries because you don't want to write everything from scratch. So you have imported different libraries made for new client and new domain, made by new employees, made by new client or new domain in the sense the people who actually are developing, they are new, they don't have domain knowledge. Made by new employees, the people who actually working there. Made for new client actually means you are developing for a new client who have not given you the right requirements, and because of those because they have not given you the correct requirements, the whole software has bugs. Made by new employees, the whole software is being developed by a team which most of the people are new in that whole team. All right. So what to remember from this lecture? If you see, there are two main things that you should remember. The first thing is the effect of measuring and managing software quality versus maintenance needs and cost. The other one is how quality can be defined. Yeah, so do you have anything to ask?